Basically, there are three types of watt done. One is called positive watt done. Next one is 0 watt done and negative watt done. Third one is 0 watt done. And I told you what is positive watt done. Positive watt done is that watt done when the motion of an object is in the direction of the force applied. Understood? If I apply the force and the object is also moving in the direction, means force and the motion of the object is in the same direction, then we call it as a positive watt done. But the next case, what does negative watt done says that if I push somebody there or if I pull something here, so what, instead of going away or toward me, it is coming to, means away, it is going away from the force applied. Okay, so if I am forcing someone here, but what happens is that instead it is coming closer to me. As I give an example of pulley. So when I try to pull something, is not it. So what happens? I apply the force downward. But what happened? The bucket of water is going upward. Means force is applied downward, but the application is in upward. So it is the complete negative direction. The direction is how much? 180 degree. 180 degree. I hope it is clear what I am saying. So what happens? In a positive watt done, suppose the force also applied here, displacement is also here. So the angle between them is what? 0 degree. But in the case of negative watt done, if the force is applied here, but the motion is here. So what happens? The angle between them is what? 180. So when the angle between the force and the displacement is 0 degree, then it is called the case of positive watt done. When the angle between them is 180 degree, then it is the case of negative watt done. And I told you about what is 0 watt done. When the force and the motion is perpendicular or mutually perpendicular, then it is a case of 0 watt done. Because no watt done, because motion is somewhere and a force is in some other condition. So what happens is that this is a case of a 0 watt done. And I already told you what is the watt done with the earth on the moon? 0. Or the earth on the sunlight? 0. Because they are maintaining a perpendicular among it. Alright, and if I say you the watt done by the sun to the solar system is also 0. I hope it is clear. Ultimately what we come means the product of what? Force and displacement is what? Is the watt done. Alright? When can one, in what are the cases, what are the conditions where the watt can be done? Watt can be done when there is a force applied, and number 2, when there is a displacement occurred in an object. Alright, clear? If I say you that if there is a change in velocity of something, can I say there is a watt done? Huh? If I change the shape of something, can I say there is a watt done? Yes. I gave you 5 different conditions. In which case you can say that there is a what? There is a watt done. What are these cases that we have learned? Yeah, come on, fast. Yeah, when a moving object, you green rest. Somebody is coming toward you, but you applied a huge force, gigantic force, and you make it stop. So this is the case of what? Watt done. If something is watt done, though it is negative watt done, but some work is taking place. Some work is obviously taking place. Now next is what when a rest body start moving, then also it is an example of a watt done. But it is not asked what is watt done. What means what type of watt done it is asked here. Now velocity of an object change or the shape of the object change. In this case, we can say there is some watt done. Alright, fine. So let me give some numerical question. Let me say that are you able to understand or not? Okay. So I have a question, kind of numerical question for all of you. Shall I dictate or what? Or shall I write for you?
Right.
Okay, fine. So the question, a coolie. Who know what is coolie? A person who carries the heavy load in his head. Come on. Do you have book with you? Anybody have book with you?
Yes.
Can I write question? Come on. Let us understand the question once. Let us repeat all together, okay? A coolie. Lift a luggage. Of 15 kg. From the ground. And put in the snare. Which is 1.5 meter from the ground. Calculate the work done on the luggage. Do you understand the question? Yes. There is a block or a luggage of 15 kg. Means we have mass of the luggage. So what is given? Very nicely write the given thing. Very nicely. What is given? Mass. Mass of the luggage. Mass of the luggage. How much the mass is? 15 kg. Alright, my dear? Yes. And from ground to the to on his head, what is the displacement? 1.5. That also we have displacement. Displacement. That is what 1.5 meter. Any doubt here? No. Fine. So alright. Now we know what is the acceleration due to gravity. What is the acceleration of the ground? It is 9.8. Is not it?
Yes.
So better to consider it 10 for our convenience. Alright. If it is mentioned take g equal 9.8, then you consider 10.8. If it is not mentioned in class 9 level, you can consider it 10 meter per second square. And we know, basically we know this, we learned already in the gravitation chapter. The acceleration is how much? Yeah, acceleration is 10 meter per second square. Alright, we consider normally. Now my dear, what to find? What to find?
Work done.
The work done by the man on the luggage. The work done. The work done. Fine, great. The work done by the man on the. So nice. I feel so nice. Now, my dear, Tanameli, what is the formula for work done? W is equal to, come on, tell me. Force into displacement. Force into displacement. Any problem? No. So far, we learned from our last class that how can you find force? Force equal to mass. I told you many a time. So instead of force, because directly force is not given. So we have to find indirectly, and we learned already in our previous chapter that F is equal to what? Mass into the acceleration into S, and we know what is mass. What is the mass of the luggage?
15.
It is 15, and what is the acceleration? 10. You have 9.8, whatever. And what is displacement? 1.5. Let us multiply it. 15 10 ja 150 into 1.5. And 15 15 ja 225. And 0 are 0 point. So how much? 225 means 225 joule. Therefore, work done is how much?
225 joule.
225 joule. I hope it is clear. Yes. Yeah. Therefore, what is found that work done is equal to 225 joule. Is there any issue, any problem, anybody? No. Shall I give one more question to you? Yes. Alright, fine. This is the question. Nice question to the class. Tapash, come on. Tapash. Kick the football. Of mass 500 gram. The football displays 70 meters and attains a velocity of 7 meters per second in 5 seconds. Find the work done by Tapash on the football. That's a very nice question. It's a good analysis of your brain. If you have really clear concept of our earlier chapter, then you can easily deal with this question. Alright, fine. So, will you show me or shall I help you out? Huh?
We'll try, sir.
So let me give you a hint for some of the students. I hope many of the students can do.
Yes.
So, my dear, the concept is that we need to find the work done. So basically, to find work done, what the main things we need? We need force and displacement. To find the work done, we need force and displacement. Is not it? Yes. So my dear, in the question already it is given the displacement. Displacement is what? 70. So our main motto is to find the force. If we get the force anyhow, then we can easily find the work done. Simple case. Now how to find the work done? It is not direct way we can find. We have to go a little earlier concept. We know that force is equal to mass into acceleration. Now still we have mass. Mass is already given. That is 500 gram. And 500 gram if you convert to the kg, it will become what? 0.5 kg. Alright. Now how can you find acceleration? We already learned in our previous chapter. That's A is equal to V minus U by T. We've learned in the earlier chapter. Isn't it? In chapter motion. We know that A is equal to what? A is equal to what? V minus U by T. Means final velocity minus initial velocity by time. Now you consider what is the final velocity of the football? 7 meter per second. And what is the initial velocity? At 0. Because before kicking the football was initially in rest. That means initial condition was 0. And time we have, that is 5 seconds. Then usually you can find it. Is not it? Yes. So we have A. If you get A, you have mass. Just if you multiply mass and acceleration, then you can easily get the force. And if you have force, just multiply with the displacement, you can get. Damn clear. I hope it's clear. Thank you. So one of the boy of your class already done it. You know this boy? The name whose name is mentioned, the same person is able to do the question. Already fine. Good. Very nice. Well done. Very nice. Good. Very nice. Very nice. If not, continue. Then Robert. Wow. you.